All right, so we're going to go over the review for Unit 2, and hopefully you'll feel like a genius on your test after this. All right, so on this first picture right here, you are to identify some pieces about this picture. So the first question says, what is the vertical asymptote? So that would be this one over here. That would be x equals -1. Make sure you're putting x equals and y equals on these things. The horizontal asymptote is right here, y equals 3. And the x-intercept. So right there I noticed the x-intercept. That is some number that's close to 0 and then 0 itself. So that would be this guy right here. The y-intercept is right here. It looks like it's at -1. All right, and the whole right there, it's at 2 something. So must be that. All right, this next one down below. What's the equation of the vertical asymptote? So I see that at -3, at +3. All right, and the equation of the slant or the oblique asymptotes. Now remember that these asymptotes are not really on the graph. They're not really there. I put them there to kind of highlight them in a way. But here's our slant asymptote right there. It crosses at 2, and I notice the slope is down 1 over 1, down 1 over 1. So my equation of my line, that's normally, it can be different things than a line, but the ones that we're going to do are going to be lines pretty much. So the slope is -1, so I'll put -x plus 2 for my equation of my line. All right, if you were asked to find or to graph this rational function, you would expect to see a slant or oblique asymptote instead of a horizontal asymptote. Why is that? Well, that is because the degree of the numerator right here is larger than the degree of the denominator. And so whenever that happens, you are going to find a slant asymptote. So you would say the degree of the numerator is larger than the degree of the denominator. Okay, so show the long division and find the slant asymptote. So here we go. So this is where I can get you to do long division. X squared plus 2x minus 4 is going to be divided into 2x to the third plus 7x squared minus 3x plus 1. Oops, kind of a funny looking one. All right, so my choice to make x squared look like 2x to the third would be to go ahead and put a 2x right here. So with that choice, 2x times x squared is 2x to the third. 2x times 2x is plus 4x, and then I get -8x. Draw a line, subtract. So I get 3x, oops, that should be a square there. 3x squared, -3 minus -8 would be positive 5x, and then bring down my 1. All right, so my next choice to make x squared look like 3x squared, I have to do a plus 3. Multiply it out, so I get 3x squared plus 6. Oh, hang on a second. 3x squared plus 6x minus 12. All right, subtract. These go away. 5 minus 6 is -1x, and then 1 minus -12 is plus 13. So that's my remainder right there. So I basically have found my slant asymptote. My slant asymptote is y equals 2x plus 3. That would be that line. All right, so on the next page here, number 4, answer the following questions, and then we're going to graph everything. So I need to factor this up so I can tell what's going on. So the denominator factors, I got multiplied to 6 and make 1, so I'm going to do x plus 3 and x minus 2 to make 1 in the middle and -6 on the end. On the numerator, I'm going to have a 2x and an x, and I'm also going to try 3 and 2. I can't put the 2 with the front ones, I'm going to put 3 here and 2 there. The outside part is creating a 4x, and this is creating a 3x. So if I make them both negative, I'll get -7x. And also, both negative means I get a positive 6. All right, so hopefully you notice this cancels. So that's going to create a hole at the number 2. We'll figure out that answer in a minute. But basically, this problem has now become 2x minus 3 over x plus 3. So before we go too far, let's go and do the domain. So the domain is all real numbers, where x can never be, well, you don't want x's that make the denominator 0. So I don't want -3 and positive 2. All right, the vertical asymptote is the x plus 3 being left over, so that the vertical asymptote would be x equals -3 for my vertical asymptote. The other part went on to become a hole, so to get the rest of that whole part, you would plug 2 into this remaining piece. So 2 times 2 on top is 4, 4 minus 3 is 1. So I get 1 over 2 plus 3 is 5, so 1/5. the horizontal asymptote, I can go back to the beginning, or I can use my result here. I can use this over that, or I can use this over this. Either way, the degrees match, and so I take the leading coefficients, 2 over 1. So my horizontal asymptote is 2. My y-intercept is when x equals 0. So I imagine that all the x's are gone. All the x's are 0. So that would mean that this is 0, this is 0, that's 0, that's 0. And so if all those are gone, I would end up with 6 over negative 6. So that would be negative 1. You can do that there, or you can do it in your changed problem here. All right, so let's mark this up. Let's see, vertical asymptote. I want to be at negative 3. All right, horizontal asymptote at 2. All right, and now the y-intercept at 0, negative 1. There's a hole at 2 and then 1/5, so right about in there. And so from here, I would just go to Desmos and type this in, but we're going to graph this, and it's going to look like that. And this other part's going to be up here. Okay, and that little hole there doesn't look too hole-ish, so maybe I will make that a little bit better. All right. Okay, so number 5. Number 5, you're asked to graph this. What would be the horizontal and vertical asymptotes? So the vertical asymptote would be x equals negative 4 because of the denominator. And in this case, the horizontal asymptote would be y equals 0. Because whenever the numerator has a smaller degree than the denominator, you say 0. All right, for these next 4 problems, you want to solve them, but remember to check for extraneous solutions. So in these problems at the bottom, number 8 and number 9, I can already tell answers that I will not accept. For this problem, x can never be negative 3 and 4 because of the denominators. And over here, x could never be 16 or negative 2 because they make the denominator 0. So those are things to watch out for. Now up here for number 6. We're going to solve this by getting the radical alone. So I'm going to take away 12 from both sides. So I get 5th root 2x minus 9 equals negative 2. And now I can come through. It's okay to have the 5th root be a negative. I'm going to come and do the 5th power on both sides. All right, so that means a 2x minus 9 comes out, and I get negative 32. Then I just keep solving. This comes out to negative 23. So 2 goes into 23, it makes 11.5, negative 11.5. All right, and so you would do a quick check. You would plug negative 11.5 back into here, make sure that it all works out, and it does. It comes out to 10 when you work it all out. All right, over here, to solve this, I'd have to get my radical alone, so I'd have to move this 5 to the other side. So you can imagine that you're moving it, or you can like take away 5 like this. But either way, you get 11 minus x inside the radical, and you have x minus 5 here. So now is the point when you come through and square both sides. So remember, when you do x minus 5 squared, that's x minus 5 like this. And you FOIL it out. And you get x squared minus 5x again, plus 25. So when you simplify it, you get x squared minus 10x plus 25. All right, and the left side just pops out 11 minus x, so that just stays there. And so now I'm going to bring everything together to the right side. I'm going to add x to both sides and take away 11. So I end up with 0 equals x squared minus 9x plus, let's see, take away 11, not 4. 25 minus 11, I wrote that a little bit poorly, and so it looked like a 4 to me. So that would be 14. All right, so now is my time to factor, because it's a square. So x and x, I would do minus 7 and minus 2 to get that 9 in the middle and also the 14 on the end. So my 2 answers are 7 and 2. Now, it's my job to go back and check those. So I should go back and plug 7 into the original problem. So square root 11 minus 7 plus 5, does it equal 7? So I'm putting in 7 for all the x's. So that's square root of 4. Square root of 4 is 2, and 2 plus 5 does equal 7. So that one's okay. The next one I would do square root of 11 minus 2 plus 5, does it equal 2 again? So square root of 11 minus 2, that's 9, so that would be 3 for the square root. 3 plus 5 equals 2, and no, it does not. So 2 is an extraneous solution. 7 is the only answer. All right, down here. On the right side, I would look at this denominator. It factors into x minus 4 and x plus 3, which are exactly what the other two are made up of. So when I go through, I'm going to make everything have the same denominator, x plus 3 and x minus 4. The next one already has x minus 4, so I would give it an x plus 3. And the last one has everything. Okie doke. So this 2x plus 13 stays. The x needs to get an x minus 4, and the 3 needs to get an x plus 3. So now that I've made the denominators match, I kind of take those away. I don't need that idea anymore. I just need to work on the top. So x times x minus 4 is x squared minus 4x, plus this will become 3x plus 9. And over on the right side, 2x plus 13. All right, so let's clean everything up. I got x squared minus x plus 9 over here equals 2x plus 13. So I got to take away 2x to get these together. I'm going to minus 13. So I got x squared minus 3x minus 4. So it's going to take some factoring. Luckily, it's not too hard. So x and x, I had a minus 4 and a plus 1 will work out. So my answers are 4 and negative 1. But, uh-oh, look up here, 4, that's not going to work. So I don't want to accept 4. My only answer is x equals negative 1. All right, over on number 9, I have to cross multiply. So I would get 2 times 16 minus x equals x times x plus 2. And you could put those on different sides if you like. But either way, you get 32 minus 2x equals x squared plus 2x. All right, I'm going to bring everything over to the right. So I'm going to add 2x there. So it becomes x squared plus 4x. And this 32 has nothing to go with. So I'm just going to bring it over to the other side and put on the end there as a minus 32. And I have a 0 there. All right, so I would go and factor this. 8 and 4 plus 8 and minus 4 work out to factor and make negative 32, but also 4. So my answers are negative 8 and 4. And my illegal answers were 16 and negative 2, but that's not these answers, so I'm good to go. All right, number 10 here. So number 10, we did this two ways. One way using a graph, one way using the sign chart, so I'll show you both. So first of all, I got to bring everything over together so I can factor and take away 3. So I get 2x squared plus 5x minus 12 is greater than or equal to 0. So we're going to factor so we can see where the x-intercepts are. I have 2x and x, or you could also graph it at this point. It's up to you. If I try 4 and 3, it's going to work out. So 4 here and 3 there. The outside's getting me 8, and the inside's getting me negative 3, so that makes my 5. So my two zeros right here are 3 halves, which is 1.5, and also negative 4. So 3 halves, 1.5 would be right here, and negative 4 would be over here. So that means when I go ahead and graph this, it looks something like this, and I can tell which part is above and which part is below the x-axis, my positive and my negative parts. Okay, so my positive area is right up here, the legs, and the negative area is right down below the hump, right down here. And the place where it's equal to 0 is right at the x-intercepts. Okay. All right, so if you're asking me when is this thing greater than or equal to 0, I'm going to say the green areas. I'm going to say for everything less than or equal to negative 4, or everything greater than or equal to 3 over 2. And the reason that I put equal bars on that is because it does say equal to 0, and that happens at those numbers. If you were doing a sign chart, you would put these numbers over here, negative 4, and also 3 over 2. And then you would put, you would go ahead and plug in some numbers. So you'd pick a number over here to the left of negative 4, like negative 5. You put negative 5 into here, put negative 5 into there. If you're putting negative 5 into here, you get negative 10 minus 3, that's negative. Negative 5 into here, negative 5 plus 4 is negative also. So two negatives multiplied together is a positive over here. So that's all we really care about. Then if you put a number in between negative 4 and 3 halves into the problem, so I would choose 0. So if I put 0 here and 0 there, I get negative 3 times 4, which is a negative number, so this becomes a negative. And then if you do the same thing to the last part, you get a positive. So look at how that matches your picture. The negative part is the part between the x-intercepts, and the positive part is to the left and right of the x-intercepts. And so that matches your answer that you want. You know, this is the area that I want. This is the green area on my graph. So if I kind of color code everything. All right, number 11. This problem over here shows a 6th degree polynomial. So we're saying this is y equals x to the 6th. So something important to note is that both ends are going up. So I know that there is a positive leading coefficient there, because otherwise they'd be both pointing down. All right, so my factors. I see this crossing at -2, at 1, and at 4. So I'm going to have x plus 2 for the -2. I'm going to have x minus 1. I'm going to have x minus 4. Now the 4 has a nice clean pass-through right here, so I'm going to put it power 1. The 1 right here has bounce, so that has to be at least a 2. And then this right here, the -2, it's passing through, but it's slow, so it jumps up to a 3. And so look at that. These, x to the 3rd, x squared, and x to the 1st, 3, 2, and 1 add up to 6. That's how you get your 6th power. And this next question, based on the picture, is a leading coefficient, the number in front of x to the 6th in the equation, is it a positive or a negative number? Well, it would have to be a positive like we discussed earlier. The end behavior of the graph makes the leading coefficient positive because both ends are going up. Okay, so remember that if something is an odd power, like let's say you had x to the 5th and there was a positive here, remember the right side would go up and the left side would go down. If it was an odd power but had a negative in front, then it would switch around. The right side would go down and the left side would go up. And even if it was an even power like this guy, but it was negative in front, both ends would go down. Okay. All right, number 12. Here told you have a polynomial function with these zeros right here, so you would automatically also know that -3i was also a 0. Remember, those occur in conjugate pairs. So if you write all your factors, there'll be 4 of them. So you'd have x minus 3i and x plus 3i. For the 1/2, remember you have x equals 1/2, so that would be a 2x equals 1, so that 1 would be over here, so it would be 2x minus 1 for your factor. And the -1 would become x plus 1. Okay, all right, for this last problem here, number 13, you are trying to find all the zeros and all the factors and everything, okay? So your first job would be to look at a picture. I would type this into Desmos, look at the picture, to save some time. There I have it. I don't know why it's all the way over there. So I typed this in, you can see, and there's my picture. All right, so look, it's crossing at 1, it's crossing at -4. And when I zoomed out and zoomed in, there was nothing else to see. So that means my other 2 answers are imaginary. So I should know to expect that when I work this out. All right, so here we go. So I forgot already what the things were. It was -4 and 1. All right, so that's what I'm going to do with my synthetic division, -4 and 1. Oopsie. All right, so it doesn't matter which one I do first. Let's do -4, and then I will do 1 after that. So I have 1, -3, -9, 63, and -52. All right, bring my 1 down. 1 times -4 is -4, adds up to -7, multiplies to 28. -9 and 28 add up to 19. 19 times -4 makes 50, no, hang on a second, 40 and 30, it makes 76. Oh my gosh, 19 times 4. Yeah, it does. 19 times 4 is 76. Sorry, yeah, I had to get my calculator. -76. So I should have done the 1 first, so it would have been a little easier. But anyway, these add up. 63 and -76 add up to -13. And that multiplies with -4 to 52. So I get a 0. Remember, if you don't get a 0, then you stop and figure out what you did wrong. Draw a line, bring the 1 down. All right, I get a 1 here, then I get a -6 when I add, then I get a -6 here, I get a 13, and I get a positive 13 and another 0. So this means that what I have left, since I just took out two x's and it was x to the fourth, this means this is x squared, and that's x right there. So I have to solve what's left, x squared minus 6x plus 13. I have to figure that out. And I can't use the graph because there's nothing else there. We have proven that -4 and 1 are the zeros, so I know that the factors are starting off with x plus 4 and x minus 1, but I still need 2 more. And so I can't factor because I can't see the answers on the picture, so I know I'm not going to be able to factor. I can't do square roots because there's a 6x here. I'll have to use my quadratic formula. So I will start off -b. Negative of -6 is 6, plus or minus the square root, b squared. So 36 minus 4a and c. A is 1, c is 13. And remember your quadratic formula is here. So the bottom is 2a, 2 times 1 is 2. So let's clean that up. You get 6 plus or minus the square root. If you work that out, 36 minus basically 52 will be -16 and over 2. So keep working that out. That's 6 plus or minus 4i over 2. So these all divide by 2, so this reduces to 3 plus or minus 2i. So there are my last two zeros. All right, so when I write them as factors, I put x minus, I put a parentheses, and I put 3 plus 2i in one of them. Then I put x minus again, put a parentheses, and I put 3 minus 2i. And that's how you take care of those ugly factors. And that is it.